let's have a look at how we divide our polynomials. So this is basically the algorithm that allows us to do it. So a polynomial is equal to this thing. What do they all mean? Well, AX is the divisor, what we're dividing by. Q then is the quotient, what we get when we're dividing it. And sometimes we'll have a remainder. So it's exactly the same as when we divide into numbers. A couple of things to point out though. The degree of the remainder must always be less than the degree of the divisor. Because if it is the same, that means, well, you can keep dividing. And QX and RX will be unique, so different things. The main reason for that is, if they were the same thing, well, then you could factorize it and you wouldn't have a remainder. Let's do some via some past HSC. Oh gosh, that is old, 1998. So they want us to find the quotient and the remainder when we divide x to the 4 minus x squared plus 1, and we're just going to divide it by x squared plus 1. So how do we do it? We set up our, well, for want of a better word, long division, but you'll notice I include the missing terms. So I put in 0x cubed and also 0x. So we need to have one term there for each of the powers, going up to the highest power, which in this case x to the power of 4. Now when we divide a polynomial into a polynomial, it's really just the leading terms you're doing. So I'm going to ask myself, what is x to the power of 4 divided by x squared? And the answer to that is x squared. And so then we get that and multiply the x squared with the divisor and write it down underneath the correct terms. So if I multiply, I'll get x squared times x squared, which is x to the power of 4, and x squared times 1, which is x squared. Then we subtract, and what we should see happening is the leading term gets eliminated. Now in this case the x cubed term does as well. That leaves us with minus 2x squared, but then we also need to bring down the terms we didn't use. So I haven't touched the 0x or the plus 1, and then we go again. So x squared into minus 2x squared gives us minus 2. Multiply out, so minus 2 times x squared is minus 2x squared. Minus 2 times 1 is minus 2. And we subtract. Again, we see the leading term disappears. And we're left with 1 minus minus 2, which is positive 3. That is our remainder, because the degree is now less than the degree of the divisor. I've got a constant number and I'm dividing by a quadratic. So in answer to their question, what is the quotient? Well, the quotient ended up being x squared minus 2 and the remainder ended up being 3. Divide the polynomial, so this quartic, by x squared minus 3x plus 1. So let's do that one. So again, the leading term into the leading term. X squared into 2x to the 4 gives us 2x squared. Multiply it out, do a subtraction, leading term disappears. So now we go into x cubed. So x squared into minus 4x cubed, minus 4x. Multiply out, subtract, again, leading term disappears. So now x squared into minus 2x squared, and we get minus 2. Subtract, and that's where we stop. We've now got a remainder of minus 1, which the degree of that is less than the degree of the divisor. So there we are. We've done our division. Part 2 of the question then said, all right, we'll write it out into that algorithm. So we'll rewrite it so as it is the divisor times the quotient plus the remainder. And there it is. So back to graphing of polynomials then. And so we know, well, if I have a polynomial divided by another polynomial, so that sort of graph is what we want to do, we can always break it up using our division. And what we should see it happening is it'll be the quotient plus the remainder over the divisor. Because essentially this fraction is saying divide polynomial x by ax. Now when it's in that form, it gives us a lot of useful information. The bottom of the fraction, so the divisor, we use that to find the vertical asymptotes, because the bottom of the fraction can't equal 0. The quotient ends up being the horizontal or the oblique asymptote, depending on the degree of the quotient. The remainder, we can solve that one to work out if it does indeed cut the horizontal or the oblique. Remember, a curve can't cut the vertical ones, but it can cut horizontal or oblique ones. So let's try it with this. We're going to sketch y equals x plus 8x on x squared minus 9. So vertical asymptotes, the bottom of the fraction, the divisor, can't equal 0. So x squared can't equal plus or minus 3. They will be our vertical asymptotes. Draw those in. There they are. The quotient ended up being x. So there'll be an oblique asymptote at y equals x. Draw that in. Now, will it meet that? And in this case, yes, it will. Because the remainder, 8x, it is possible for that to equal 0. At x equals 0. Therefore, I know this curve will go through the origin. That is what this curve then looks like. Well, we can go through and work out where x-intercepts are and things like that to work out. We've got to bend towards the asymptotes, things like that. We can fill in those gaps. So 10C.